What if we and our entire universe were in a black hole? Some suggest that we must accept that we will never understand the answers to such questions. After all, even the James Webb Space Telescope, the most powerful telescope in history, can see 100 million years after the Big Bang, according to NASA, but it still can't see through moments. The first engraving of existence. Some researchers think that the universe exists as a single, dense, and infinite point, called a singularity. That singularity broke off and hasn't stopped expanding ever since. This is essentially the opposite of black hole properties. A black hole is also an infinitely dense point in space-time. However, instead of spitting everything out, it sucks everything in. Could the formation of a black hole mean the creation of a new universe within it? The supermassive black hole TON 618 is the largest black hole entity ever detected in the universe. Possessing a tremendous weight and size, this black hole is truly a monster when it is constantly gobbling up the matter at the center of its galaxy. So what is this black hole called TON 618 really? Find out with AskPop in today's video. Initially, scientists used the hypothesis of the merger of small black holes to explain the existence of large black holes. But when learning about the existence of a supermassive black hole called TON 618, this merger hypothesis began to shake. Another theory is that the collision of stars inside star clusters led to the formation of massive stars that would later become a medium-sized black hole. These black holes attract each other at the center of the galaxy to continue merging to form super black holes. Another theory put forward by scientists is that black holes like the supermassive black hole TON 618 are formed from ancient types of stars called quasistar. The core of this star is a black hole. This is a supermassive and super bright star that could only exist in the early universe. Quasistars were originally formed from young stars that were in the process of absorbing matter on the accretion disk. However, due to the large mass, it leads to the formation of a black hole in the core. Over time, the outer shell is compressed inward, and the result is a massive release of energy equivalent to a supernova explosion. But because the young star's shell is too thick to be blown away from the core, it inadvertently absorbed all the energy and was unharmed. At that time, gravity pulls the material of the new shell towards the center. The energy released by the black hole makes the state of the newly formed black hole star in a stable state. At the current rate of development, the supermassive black hole TON 618 will continue to expand in both size and mass. Scientists hope that soon, more supermassive black holes of similar size will be discovered and hope that they can reveal more secrets to humanity about dark matter, dark energy, or dark energy. Other secrets about the universe in the not-too-distant future. This massive supermassive black hole was first discovered in 1957 during a survey from the Tonantzintla Observatory in Mexico. Prior to 1963, quasars were still unrecognized, so the 1957 observation of TON 618 was assumed as an unknown object. This was done while investigating pale blue stars, white dwarfs, located far from the planet of the Milky Way. On images taken with the Tonnant-Sintla National Observatory's 0.7-meter Schmidt telescope, it appears as a faint purple streak and is listed as number 618 on the Tonnant-Sintla list. In 1970, a radio survey in Bologna detected radio waves from TON 618, indicating that it was a quasar. Marie-Helene Ulrich then obtained a spectrum of TON 618 at the McDonald Observatory showing spectral lines typical of a quasar. From the redshift of the lines, Ulrich deduces that TON 618 is very distant, and therefore one of the brightest known quasars. Black holes are among the most massive objects in the universe. TON 618 powers the central quasar, the brightest object in the universe with a luminosity of 140 trillion suns. Quasars are powered by supermassive black holes and can glow for millions of years. However, quasars are so far away that they look like faint dots even when viewed with the most powerful telescopes. Astronomers first detected quasars through their intense radio emissions. Quasars are actually supermassive black holes through mergers with other black holes and regularly eating surrounding matter. According to scientists, there is still a limit to the size of a black hole, and the main determining factor is how fast it eats. Black holes can only consume matter for a certain amount of time. When matter falls into a black hole, it heats up and releases radiation, but that radiation heats up the matter, preventing it from falling quickly into the black hole. It is this self-regulatory process that prevents the black hole from growing too quickly. This eating rate is the factor that limits the size of the black hole. They can only consume matter for a certain amount of time. As matter falls into the black hole, it heats up and releases radiation. But that radiation heats up matter, preventing it from falling rapidly into the black hole. The self-regulatory process prevents the black hole from growing too quickly. Astronomers estimate a black hole's maximum mass based on the rate at which it eats and multiplies with the known age of the universe. Up to now, the largest black hole ever discovered has a mass 66 billion times that of the Sun and is located quite far from Earth, 10.4 billion light-years. TON 618 is located at the boundary between the constellations Canes Venatici and Coma Berenices, about 18.2 billion light-years from Earth. The huge size of this supermassive black hole at the center of the quasar has led scientists to question whether there are other supermassive black holes of the same size as TON 618. According to cosmologist Florian Kühnel at Ludwig Maximilian University, Munich, Germany, it is theoretically possible that black holes similar to the supermassive black hole TON 618 could exist. The superquasar above emits an extremely large light source because the supermassive black hole located at its center is working at full capacity. The speed of this supermassive black hole is so strong that it cannot digest in time matter it absorbs, resulting in the generation of extremely large electromagnetic radiation. The luminosity emitted by quasar TON 618 is extremely powerful, possibly even thousands of times the luminosity of a galaxy the size of the Milky Way. TON 618 contains a supermassive black hole 66 billion times the mass of the Sun at its center. The diameter of the black hole is about 390 billion kilometers, more than 40 times the distance from the Sun to Neptune, the most distant planet in the solar system. This supermassive black hole has even more mass than all the stars in our Milky Way galaxy, only about 64 billion times that of the Sun. And it is 15,300 times heavier than the supermassive black hole at the center of Sagittarius A*, or Sagittarius A star. The size of TON 618 can be inferred from the quasar's brightness. From this size and rotational speed, calculations suggest that the mass of the central black hole is about 66 billion times the mass of the Sun. With this mass, TON 618 belongs to a new subclass of supermassive black holes. The Schwarzschild radius corresponding to this mass is in the order of 1,300 Australian dollars, astronomical units. The existence of black holes like TON 618 gives scientists a real headache. It is not entirely clear how supermassive or supermassive black holes form and develop. It is still unclear how black holes can reach such massive sizes while the universe is still in its infancy. Thank you for watching today's video. If you find this video good, please like, share, and don't forget to subscribe to the channel to support Ask Pop Entertainment to make more exciting videos.